Let me show you something that every engineer learns the hard way. You can deploy the best model in the world today and still have it fail silently next week. Not because the code is wrong, not because the server crashed, but because users started talking differently. Users started talking differently. That's data drift. And if you don't catch it, your AI system becomes dangerously useless while everything still looks healthy. Today, we are going to fix that. I'm going to show you how real companies monitor AI models in production using FastAPI, Prometheus, and Grafana. By the end of this episode, your model will scream the moment it starts failing. Before we dive in, hit like, subscribe, and comment. Drift happens. So YouTube knows you are actually building real MLOps skills. Here's the truth nobody tells you. Machine learning models don't break in obvious ways. They break when the world changes. New slang, new patterns, new behavior, new distributions. So your model stays the same, but reality moves forward. That's when accuracy quietly drops from 85% to 40%. And nobody knows until customers scream. This episode is all about detecting that drop before it becomes a business disaster. Alright, let's jump into the demo. This is MLOps episode 6. I created a virtual environment, followed by we have a data folder, Grafana folder, model folder, Prometheus folder, and we have docker compose.yaml file, a docker file, a readme.md file, and requirements.txt file. So first of all, I would like to train our model real quick. So I'm going to run this command, python space model train underscore good model.py, which I already did in previous episodes as well. So I'm doing the same thing once again. So we have the good model accuracy 1.0, and we can see artifacts underscore prod pipeline.pkl file in place. Now comes the exciting part. We are turning our fast API into a fully monitored ML microservice. So here, if you look at this particular file, here we added request underscore count to track all predictions, prediction network, prediction billing. So we can see shifts like why are 90% of predictions suddenly billing. Followed by we have text length histogram. Shorter or longer message can indicate new user behavior. Then we have model version. We can visually see which model version is currently live. And then we have in distribution, out distribution detection as well. This is the real drift detector. We define some unseen slang. For example, if you see seen out, 5G gone, RIP net, Wi-Fi CapCut. If the input text contains any of these, we increment out of distribution. This is not perfect ML, but it's a perfect demo how companies detect drift patterns. Now let's run this like a real production system. So I'm going to jump back to my docker compose.yaml file. If you see, we use Docker Compose to start our monitored API, for example, ML API. Then we have Prometheus for scraping our metrics, followed by we have Grafana for dashboards. Now we are going to run Docker Compose up -- build, press enter, and all our containers will start running. This is exactly how companies deploy monitoring stacks beside ML services. Our containers are up and running now. I'm going to jump back to the browser, and in the browser I'm going to navigate to localhost 1990. We are in the Prometheus server now. Here I'm going to search for ML request total. Okay, click on execute. I can see some metric, followed by I'm going to do the same for ML input in distribution underscore total. Click on this and execute. I can see this metric as well, followed by the same for out distribution total, ML out distribution underscore total. Click on execute once again. Here we can see all these metrics. Prometheus is pulling live metrics from our FastAPI service. Now watch what happens when I spam some inputs here. Now let's jump back to our Swagger UI. Here let's try to write some message. For example, I would try to add my network is not working. Okay, this is, let's say, a normal in distribution example. Okay, executed. We can see the output here. That's fine. And also I will try to add one more message here real quick. So I would say I would remove this real quick and then we can add. So I will add, why is my bill so high? Okay, this is also in distribution. So we are trying to add very nice, messages. Now let's try to add some slang messages. For example, I will try to add seen out net. So I will remove this and I would say seen out net, execute. Okay, this works. I mean, I'm going to get the output. So end goal I'll try to show you in a moment. Followed by I would say 5G gone bro. Okay, execute. Now let's jump back to our Prometheus server. Here, if you see ML input out of distribution messages, I'm going to click on this graph. You see the spike? So we have sent so many messages. That is the reason we are seeing this spike in the graph here. Whereas I will go with ML in distribution, for example. So let me search that real quick, execute, and underscore total. If we look at this particular graph here, once again we can see the spike. That's drift in real time. Now what we are going to do, we are going to open Grafana dashboard real quick. So I'm going to open another tab. I'm going to give username and password. Click on login. It is asking me to update password, so I'm going to update that real quick. Submit it. Followed by, here we are going to create some panels. For example, I would like to create out of distribution drift panel. I'm going to go to the dashboard, create dashboard, add visualization here, select Prometheus as, let's say, the default here, and here I would say out of distribution drift. And in the query I would add a simple query. For example, I would add a prompt QL query saying rate ML input out of distribution for every 1 minute. Okay, and I would like to save this as a graph. Save this and give it a name. So name would be ML model. Save. Back to dashboard. We are going to create some other panels as well. For example, second panel would be prediction drift. I would add visualization here. Title would be prediction drift, and then prompt QL would be, I'm going to add both network and billing total. So I'm going to execute this. Once again, I would select bar graph here, save the dashboard, save, back to the dashboard. Then the third panel would be request traffic. Click on add visualization. Title would be request traffic. And in the request traffic, I'm going to add rate ML request total. Okay. Then once again, I would give bar graph here, save, back to the dashboard, and I'm going to add text length behavior. So all these panels will give us proper visualization. So I'm going to add this here, followed by, I would say, histogram quantile 0.95 rate ML text length bucket for every 5 minutes. Okay, save this. Final panel would be model underscore version. So I would add it here, model version. Then we ask ML model version. So I would say ML model version in the PromptQL query. Save it, go back, and now we can try to adjust these panels. I'm going to drag it a bit here and keep it like this. So let's try to refresh this. And if you see, we can see some model version here. So here I see model version as 222. I don't want bar graph, so I would like to change this. For example, let's keep it as stat. Go back to the dashboard. I can see model version as 2. And if you see, we can see request traffic as well. Now if you see, we created 5 different panels, and it is also showing us all the graph details. For example, out of distribution drift, request traffic, prediction drift. We can see clearly this dashboard is more observability than 90% of ML startups ever set up. And we built it in few minutes. It is trying to scrape everything using Prometheus, and we are trying to display it here. Why drift monitoring matters. This system now warns us instantly when users are typing a new slang, model predictions shift, model predictions shift, request volume spikes, model version is outdated, input looks different from training data. This is the difference between we deploy a model and hope it works, and we deploy a model and know when it stops working. And that's episode 6. Today we built a monitored ML microservice, a Prometheus metrics pipeline, a Grafana dashboard, a drift detection system, real world production observability. This is real MLOps, not theory, not a Jupyter notebook, production grade engineering. In episode 7, we connect monitoring, drift, auto retraining, CI/CD for fully automated ML lifecycle. Hit like, subscribe, and comment. Drift happens if you are ready for episode 7. Thank you for watching and see you in the next video.